Good evening, Sampat.
Good evening, sir.
Good evening. Good evening, Pranav. Good evening, Jitendra.
Good evening, sir.
Good evening, sir.
Good evening. Okay, so now we can start. So in the last class, we have discussed about motion chapter. We have completed motion chapter. So in the last class, we discussed about motion, and in that, the last topic that was discussed was uniform circular motion. So today we'll be starting with the new chapter, that is force and laws of motion. We need to understand the force and the laws of motion.
Good evening, sir.
So let's start. Yes, anyone having any doubt regarding the circular motion, so can ask, clarify this. Then we are just starting with the uniform circular motion. So I don't think anyone is having any doubts. In the last test also, I saw that most of you have scored well. And this time, whatever test you are having, just see that you should be getting well. You should be getting all the good marks. So let's start with this. Force and laws of motion.
Sir, I had a doubt.
Yes.
Sir, where did I lose 1 mark in the paper?
I think you lost 1 mark in long answers. What's your name?
Sir, Rohit.
Right. Okay. I'm showing you your notebook. I hope you haven't seen your notebook, right?
No, sir. I just got the marks today, sir. I saw it on the
Okay.
Bible.
Okay. Just 1 minute. Let me show you a copy. Rohit. Yeah. So see, you got here Rohit. Yeah.
Yes,
You
sir.
got 1 mark less in chemistry. In physics, you got
Oh,
20 on.
okay, sir. Sir, my graph was clear, right, for the last
Yeah.
question?
Yeah. Your graph was correct. It's here.
Yes, sir.
All of you can see this is the graph of the last question. I think this was the only doubt most of you people might have faced.
Yes, sir.
Okay. So you were given a displacement time graph, and from that you had to make a velocity time graph. Okay. So in the first 50 seconds, it was an increasing graph, and the next 50 seconds it was a decreasing graph. So we
Okay,
had
sir.
obtained from that graph, we calculated the velocity. The velocity came out to be 2 meter per second. In the first part, the velocity was plus 2 meter per second, and in the second part, the velocity was minus 2 meter per second. Okay, so what do you think? This paper was the same as the previous one, or was this a tougher than the previous one?
Sir, a little tougher than the previous one. Not that tough.
Yeah. So see, up to now we have taken around 5 to 6 tests of the chapter motion, or even more. So in every test, we increase the level of questions now. Now, whenever if there will be a test of motion chapter, so don't expect the questions to be the same level. The levels will be tougher. Got it? So I think now we can start. Anyone else having any doubt?
Sir,
Yes.
yesterday I was absent. What had happened in the class yesterday?
Yesterday you didn't have physics class.
Okay, sir.
Okay. So let's continue here with force and laws of motion. You have studied about force in your class 8, where we defined force to be a push or pull. So we define force to be a push
Or a
or
pull.
a pull. So a push or a pull is called as a force, and this is simply what we have said. So if you are experiencing a push, that is a force. If you are experiencing a pull, that is also a force. So that is what we have seen about the forces. Here we define a force to be, we define force something like this. We say that it is an interaction between two objects. So force is an interaction between two objects. It is an interaction between two objects that tries to change the state of motion and shape of the object. So it is an interaction between two bodies. If the two bodies, they are interacting with each other. So how do they interact? They interact with each other either by pushing them or pulling them.
Yes,
Okay.
sir.
So the interaction between two bodies that tries to bring about a change in the state of motion or in the shape of the object, we call it as the force. As we have seen that forces are of different types. You have seen about the contact forces and non-contact forces. Can you tell what are contact forces?
Sir, the forces that are act when the objects are in direct contact or the who is applying the
Yes,
forces
sir.
is the object.
Okay. The forces which are which come into effect or which can be applied only when the two bodies are in a direct physical contact with each other. So we had seen here the types of forces. This was in our last class, not this last class. In your grade 8th, you have studied about the types of forces. As the type of force, we had seen contact and non-contact forces. So this was based on the basis of contact, whether they make a contact or not. So in the contact forces, can you name some of the contact forces?
Sir, electrostatic force, magnetic force.
No, just
Sir,
contact forces.
Yes, sir.
frictional force.
Sir, muscular force.
Yes, our muscular force is a contact force,
Sir,
and and
frictional force.
Frictional, sir.
yeah, muscular force and frictional force, they are the contact forces.
Sir,
Can you name some?
gravitational force is non-contact, right?
Yeah, gravitational force is a non-contact force. So if you look for non-contact forces, they are the gravitational.
Magnetic force.
Yeah, gravitational,
Electrostatic force.
magnetic, and electrostatic.
Yes, sir.
Gravitational forces, magnetic forces, and electrostatic forces. So all these forces, they are the contact and non-contact forces. We have also seen the types of forces on the basis of whether the forces are balanced or not. So this is another type, the type of force we can also say on their
Sir,
balancing nature. So on the balancing nature, we can say whether the forces are balanced or unbalanced.
non-balanced. Yes, sir. Unbalanced.
Okay. So what are balanced forces?
Sir, balance force need to have net force zero, no sir.
Yeah, net force has to be zero. If
Mhm.
two or more forces are acting on an object and their net sum is zero, then we say that the forces are balanced. Okay, so what are the balanced forces? We can write here. If two or more forces act on an act on a body such that their sum is zero, then the forces are balanced. So we'll be giving you here some of the examples of the balanced forces
Sir.
and some examples for the unbalanced forces. So you will tell me whether in which of the cases you have the forces to be balanced and in which cases we have the forces are unbalanced. So we take here objects. Okay. So here you have, let's say, okay, see. So here I have given you some of the examples. Here, suppose if you have a force of 2 Newton and here you have a force of 5 Newton. Here you have two forces, here force of 2 Newton, here also 2 Newton. Here you have force of 5 Newton, here you have a force of, okay. So in which cases do you see that the forces are balanced? Let this be the first, second, third, and fourth. Okay. So in which case we have the forces are balanced?
Sir, B.
Sir, B, C.
B, C, and
Okay. Let's start with A. What can we say about A? Are the forces balanced or unbalanced?
sir, unbalanced because the net
Unbalanced.
force will be 3 Newton.
Okay. So here we observe that the forces are unbalanced. Okay. What about this one B?
Sir, balanced 0
Okay.
because the net
Here
force is 0.
okay, here the forces are balanced. What about the C?
Sir, balanced because
Okay,
net
C.
force is 0.
Okay. What about D?
Sir, unbalanced.
Okay, D is unbalanced.
Yes, sir.
Sir, will the answer be negative 5 Newton, the net force?
No, the answer is 5 Newton.
Okay, sir.
Next. Okay. I give you some more examples. You will be telling that whether the forces are balanced or not.
Yes, sir.
So here you have the force of 10 Newton, here also 10. So is this balanced?
Yes, sir.
Yes, sir.
Okay, I want everyone to speak up during the classes. Everyone. And I can see all the cameras are off. So you have to be present in the class. If your camera is on, so you are marked as present. I know that yes, you are present. If your camera is off, so that shows your absence. That shows you are busy somewhere and just join it. Okay. So still I can see Rohit, Mohammad Rayan, Harshit, Pranav, Akshara, cameras off. Okay, so your camera should be on. And in the beginning, when I told you, if you are facing any issue with your camera, if there is any technical issue, do message through the help and support group. You can drink water, you can eat, you can do your work right sitting over there, you can study, but do not keep it off. Okay, just pay attention here. So we have seen what are the balanced forces and what are unbalanced forces. Now I think everyone is aware that in the balanced forces, if the sum of a number of forces is 0, then we say that the forces are balanced. And if the sum of the forces are not 0, so then the forces are unbalanced. So what do you think? What effects can be brought about by the balanced forces? If the forces are balanced, can there be any effect?
No, sir. The object will be at rest only.
Yes, what will be there?
Sir, the net force will be 0 and there will be no change
0
on the.
Newton, sir.
Okay, there will not be any change in the state of motion, but will there be any other effect that can be brought about by the balanced forces?
No, sir.
No, sir.
Okay. Can you just press a balloon? I want to press a balloon to change its shape. As you know that you can change the shape of a balloon by pressing it. Okay. So you have to press that balloon, but just with one hand and without your hands being folded, without taking any support. That means you are not making the forces balanced. You are just, you can just put the balloon on your hand. So do you think that there will be any change in the shape of balloon?
No, sir.
Why? How can you bring about a change of shape? Yes.
Sir, when
Okay.
Sir,
the
the hammering force.
static force.
Yeah. Okay. Have you seen an ironsmith hammering any object or a goldsmith hammering any object?
Yes, sir.
Yeah. So when a goldsmith and an iron blacksmith hammers an object, he puts a support below that iron piece. Why the support is required there?
Sir, to oppose the force that is applied on the
Yeah.
upward.
Yes. So to oppose the force, it is something like this. If you are keeping, let's say here, this is the surface. So you provide a support from the bottom. You are providing a support from the bottom. And on this support, you are keeping a piece of iron or any substance, and then you hammer it from the top. So after that, if you hammer from the top here, so you are applying some force from the top. Here you are applying some force from the top on this, and when this applies the force, so it doesn't go down, and a reaction force is being set up from the bottom. As a result, the forces are balanced. So a change of shape can be brought about by the balanced forces. If the forces are unbalanced, you cannot bring about a change of shape. Got it? Yes? So the change of shape can be brought about by the balanced forces. So what if I ask what the balanced forces can do? Balanced forces, they can change the shape of an object. I'll show you one. Can change shape. Okay. For example, look at the option E. Can you see option E?
Yes,
Here
sir.
option E. Are the forces balanced?
Yes, sir.
Okay, so what will happen to the ball in between? Won't it
Sir,
change its shape?
yes,
Sir.
sir. It is.
Yes, it will change its shape. The shape of the ball will be changed, even if the forces are balanced. What do you think about this one? The case B.
Sir, it's
Sir,
in the
it
middle of both the.
extended,
Sir,
sir.
it's balanced. It's not.
Yeah, it is balanced. The B one is balanced.
It
So what
becomes,
effect can it bring about?
sir, it is changing
Sir,
shape
it
by.
can.
Yeah, it can stretch. Yes, Sampath, you're correct. It will stretch. Okay, it will stretch the ball. So the balanced forces can bring about a change of shape. Okay. So in any of the cases, you can see the balanced forces, they can bring about a change of shape. Whereas an unbalanced forces, let us see what you will observe in the case of unbalanced forces. So can you tell what the unbalanced forces will do?
Sir, it will change the shape of motion.
Unbalanced forces, it will change the state of motion. See, every point, every word that we are saying will hold a significant meaning in the definition. Okay. So unbalanced forces, they change the state of an object, change the state of object or say state of motion, change the state of motion. So the unbalanced forces, 1 minute. Hello, 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 hello. ठीक है डायरेक्ट बोला था ठीक है बस 10 मिनट ठीक हाँ हाँ ना फिर क्लास वाले ली हम्म okay see so here we observe that unbalanced forces they can change the state of motion of an object. That means if an object is stationary, so they can make the object move. If an object is moving, so they can stop. It can also change the direction of motion of an object. Okay, so unbalanced forces they can change the direction of motion of the object. They can make a moving object stop. They can make a stationary object move. They can speed up an object and they can slow down an object. Okay, so these are the effects which are created by a balanced and an unbalanced forces. Okay, so if the forces are balanced, they can bring about a change of shape. If the forces are unbalanced, they will bring about a change in the state of motion. Now here in this chapter, we are going to mainly discuss about the unbalanced forces. Okay. So before that, now let's start with the main topic starting with inertia. Okay. So the habit, what is the tendency of an object? So what is your tendency that we want to discuss here? Tendency of an object. Okay. So the natural tendency of an object. Okay. Do you think that if you keep a ball in your home at some place, okay, suppose after coming from your school, you keep your book in your almirah, okay, so do you expect your book to be there?
Yes, sir.
Yes. How long do you expect that your book will be there?
Sir, until we take it out again.
Yeah, until you take it away, the book is supposed to be there. So I can say that the natural tendency of the book is to be there at its own place. Yes, I can say that the book will not move on its own. Okay, so this property is called as inertia. The natural tendency of the objects towards motion is called inertia. But we'll try to understand this in detail how the scientists have gone on study. So natural tendency of motion, natural tendency of bodies towards motion. Okay, what do you think about a moving object? If you have an object which is moving, so what should be the natural tendency of that object? Should the natural tendency of that object, so should that object come to a stop?
Sir, it will come to stop if external force is applied like friction. If not, it will go on.
आज बोलिए नहीं कोई नहीं ये अभी मेरा एनरोलमेंट शो नहीं हो रहा था नहीं अभी नहीं हो रहा है थोड़ी देर बाद आपको फोन करता हूँ fine we were saying the natural tendency of the object is to be at a rest. If it is at a rest, so it is to be at a rest. And what about if the object is moving? So what is its natural tendency?
Sir, it should be moving if no external force is applied.
Yeah, so the natural tendency of any object towards motion is that to maintain its state. Every object, it wants to, or its natural tendency is to maintain its state. Okay, so natural tendency of an object, of any object towards motion is that to maintain its state. Oh, oh, I haven't shared the screen.
No, sir.
No, sir.
No, sir.
The natural tendency of bodies towards motion, that it doesn't, all objects, all bodies maintain their state of rest or of uniform motion. Or of uniform motion. Right? So the natural tendency of bodies towards motion is that all bodies, they maintain their state of rest or of uniform motion in a straight line. Okay. So initially this was understood by some to be a false statement. Initially it was Aristotle who studied, and he studied, he found out, he said that yes, it is a natural tendency of all the bodies to be in the state of rest. Okay. So he found out that all bodies should be in the state of rest. Jitendra, are you there? Jitendra Reddy? Yeah, Jitendra, are you there?
Yes, sir.
Okay. So see, the natural tendency of all the objects, generally what we observe in our surroundings. We observe that if you throw a ball, it comes to a stop. We do not find any object which is moving infinitely. Have you seen any object which is moving infinitely and continuously? The answer is no. We
Sir,
haven't seen any. We haven't seen any object which can move infinitely. So here we see that the natural tendency of the object is not towards rest. So that was founded by Aristotle. He studied. He said that all objects, they have a tendency to come to a state of rest. Finally, it was Galileo Galilei who said that it is the tendency of all the objects not to be stationary, but to remain in their state. If they are in the state of rest, so they must remain in their state of rest. If they are moving, so they must remain in their state of motion. Okay. So this natural tendency of the object to maintain their state of rest or of uniform motion in a straight line was called as inertia. Okay. So the name given to this was inertia. Now can you define inertia? Yes. What is inertia?
All bodies maintaining their state of rest position.
Yeah. The not the rest position. Inertia is the tendency of all the bodies to be in the state of rest or of uniform motion. So all bodies maintain their state of rest or of uniform motion in a straight line. This is called as inertia. We'll see certain applications of inertia. What are the different things that can be explained with the help of inertia? So if you are asked what is inertia, the tendency of a body to resist any change in its state of motion. Here, another definition for inertia. We say inertia as the tendency of a body to resist any change in the state of rest or of uniform motion. Straight line. So all bodies, they resist their changes in the state of rest. They do not want to change their state, they resist it, and this we call as the inertia. A measure of inertia is the mass. So what is inertia? How do we measure it? We'll see two different aspects, how we measure the inertia of an object. Okay. So what is inertia? The tendency of a body to resist any change in the state of rest or of uniform motion. So see, how do the object resist these changes? Suppose if you are standing in a bus and the bus tries to move. Okay. So the bus accelerates and it tries to move. What will happen to you? Will there be anything that will happen to you?
No.
No. So why?
Sir, due to inertia.
No, see. There will be something that is going to happen. If your bus starts to move all of a sudden, so you are going to get a backward jerk. Right? If your bus starts moving, suppose the bus starts moving along this direction. So if it starts to move all at once, so it accelerates. Here the bus accelerates, it was at rest, and now the bus starts moving. So the bus accelerates towards the right. Now the passengers who are inside the bus, all the passengers who are sitting inside the bus, all the passengers, they will feel a backward jerk. Have you ever felt a backward jerk?
Yes, sir.
Yes. So all the passengers who are sitting in this, they will be feeling a backward jerk. So here it will experience a backward jerk. This object will also experience a backward jerk. So why it happens? It is because of the tendency of these objects. The tendency of these objects is to be in the state of rest. Because initially the bus was in the state of rest. Bus was stationary. So all the passengers, they were also stationary. Now when the bus started to move, all of a sudden the bus started accelerating. The tendency of the passengers is still to remain in the state of rest. They do not have a tendency to go with the bus. So that is why, because of this tendency, all the passengers, they feel a backward jerk. Okay. So understood this? Why do the passengers feel a backward jerk?
Sir,
Yes.
sir, even the bus when stops us, suddenly we feel we fall front no, sir. That's also the
Yeah.
phenomenon.
Yeah, of course. If the brakes of the bus, they are applied all of a sudden. If all of a sudden the brakes of the bus are applied, so what will happen? If all of a sudden the brakes are applied, the passengers, they will fall in the forward direction. Why? The reason being that when the bus is traveling with a certain speed, the passengers do have a tendency to travel with that speed. The passengers, they have a natural tendency to travel with that speed. Right? When the bus takes a sudden break, so the passengers having their natural tendency to travel with that speed, they continue to travel. So the passengers, they continue to travel with the same speed in the forward direction. Okay. Whereas the bus is at the state of rest. Okay. See, the bus is stationary, but the passengers are still moving in the forward direction. So they will experience a jerk in the forward direction, or they will fall off in the forward direction. The same thing happens when you have a collision between two buses or a collision of any moving vehicle. So you observe that if a moving vehicle collides, the vehicle comes to a rest all of a sudden, but the passengers over there, or the head of the passenger, the body of the passenger, it moves out. it moves in the forward direction, and hence all the passengers and the driver or the people, they get injured. Okay. So understood the inertia concept here in both the cases?
Yes, sir.
Yes, sir.
So in both the cases, we see that there is inertia. In one of them, you have inertia of rest. In the other one, you have inertia of motion. We'll talk of the different types of inertia. Okay. But here we have mainly talked of these two with the bus. Okay. What will happen if you jump out of a moving bus? Yes, what will happen if you jump out of a moving bus? You don't need to do this activity.
Sir,
Fall and start rolling.
Yeah, you will fall in the forward direction. Your body will fall in the forward direction. But how it is possible that a tea seller jumps out of a train and is still safe? Have you ever seen a tea seller jumping from a moving train?
yes,
Sir, if
yes.
the speed is slow, we can jump.
Yeah, so how it is possible? How it's possible that if the speed is slow, then you can jump. If the speed is
Sir,
high, then you can't jump.
sir, the inertia of rest and inertia of motion are closely the same.
No, see, when the speed is slow, then when you jump out of the train, you have to run along with it. You have to run with the speed with which the train was traveling. If you observe the tea seller, he jumps out of the train, but he keeps on running a certain distance and then stops slowly, makes a slow stop. Okay. If he tries
Sir,
to stop,
inertia is directly proportional to speed.
we will see how it is directly proportional. Okay, don't jump over there. Just we are here that if you are moving, so you have to continue moving, and slowly you can come to a stop. Okay, then you will not get injured. Okay, so by all of you will see again you all in the next class, but in the test for this Saturday, you will be getting motion only. Only motion will be a part of the test for physics.
Okay,
Got
sir.
it? Okay, by all of you.
Thank you, sir. Bye, sir.